water quality is increasingly being put at risk due to the widespread use of commercial fertilizers. Massive dead zones are developing in coastal areas due to widespread eutrophication. In some rural areas, nitrate levels are more than 10 times the drinking water standard. Lawsuits are being filed to hold farmers accountable for nitrate pollution, and the costs of dealing with these problems continue to grow. It has been estimated that it would cost $2.7 billion per year to meet water quality targets for the Gulf of Mexico.
Without commercial fertilizers, we wouldn't be able to feed the more than 7 billion people on the planet. Nitrogen fertilizer use has led to dramatic increases in crop yields. It's actually been said that more than half of the nitrogen in the human body started out in a fertilizer factory.
Watershed mass balance studies have shown that human-dominated watersheds have a persistent nitrogen surplus. In other words, even after accounting for nitrogen outputs from watershed in crops and in surface water, a large portion of nitrogen inputs remain unaccounted for. We are finding this nitrogen is actually accumulating in the root zones of agricultural soils, just below the plow layer. In fact, in our study, we find that this nitrogen accumulation in the root zone can account for a large portion of the missing nitrogen identified in mass balance studies.
In our study, we analyzed long-term soil data from more than 2,000 sites across the Mississippi River Basin, and we found accumulation on the order of 140 teragrams of nitrogen. And in many areas, this accumulation was not present in the upper 25 centimeters, the so-called plow layer. In fact, in these layers, we actually found a depletion of nitrogen. In the lower layers, however, we found significant accumulation on the order of 50% of the nitrogen surplus. What this means is that more attention must be paid to the potential for nutrient legacies throughout the soil profile.
Our results suggest that the legacies of nitrogen in soil and groundwater can lead to long time lags between a farmer taking action at the field scale and seeing measurable improvements in water quality at the watershed scale.
Since the 1970s, a range of stakeholders, from farmers to policymakers to conservation authorities, have been working to implement best management practices to reduce the leakage of fertilizer from agricultural fields to groundwater and to nearby lakes and streams. Unfortunately, nitrate concentrations have remained stubbornly high. At a practical level, there's a great deal of frustration about not seeing results after conservation measures are implemented.
Our modeling results suggest that the legacy nitrogen in the landscape could be leaching into the waterways more than 3 decades after you stop applying the nitrogen to the fields.
Such legacies must be taken into account when attempting to understand long-term nitrogen dynamics and when setting policy goals regarding improvements in water quality.
To help set policy goals, it is critical to quantify these legacies and time lags in human-impacted landscapes across the world.